Hello, our guest is Marlene Bosquez. She's a PhD student in Eötvös Loránd University in Budapest. So, Marlene, the floor is yours. So tell me about your research.
So what we are doing is studying the atmospheres of other planets, like let's say Titan, which is Saturn's largest moon, and also here in planet Earth we have certain components in atmospheres. So we are kind of investigating them.
So, what it is needed for?
Oh, for that we are doing a computational approach, which mostly is determining intermolecular interactions in some of these samples. Let's say we call them dimers, which is a mixture of two molecules. And we are studying those interactions, what is going with them, their energies, their approximations, how they interact, in order that maybe at some future, if we determine how are they behaving in the atmospheres, we can have some guesses of how the environment or how those atmospheres could be affecting potential other things in the future.
So who needs those data? Can you say, I mean, like, who actually will use later those data?
We're trying to complete the spectroscopy, a spectroscopy table, in which we're going to trying to help other, let's say, NASA and other studies with the spectroscopic data. So what we are kind of telling is that, okay, we have these energies, you can identify this molecule using this, let's say, spectra, and that will work as a fingerprint. Therefore, if we use that data, we can say, or we can approximate or trying to understand what amount of gas or some component in the atmosphere will be there.
So what is your first goal? What kind of atmospheric gas?
Oh, the first one will be N2 dimer, but I'm also working with CO dimer.
So N2 is like the main component of Earth's atmosphere, so you were studying air in some sense, right?
Yeah, it's like 70 and higher, but 70% of the main component in Earth. But yeah, it's kind of interesting. How can we use this kind of data and not only understand what we are living, but also to extrapolate it?
So actually, it's kind of nice. So you can predict the property of air just using chemical methods, right? Quantum chemical methods,
yeah.
Right? So what actually you in rigorous way in chemistry, how you start with your calculation?
Oh,
what you do?
So there are some steps, but the easiest one is, for example, the first step is to do some previous research, because you need to know if someone else knows something about that. Then the second one will be, we call it optimizations, in which you determine the most probable electronic structure, or the structure in which the molecule or this system, this dimer, will be. Then the third one will be to generate a potential energy surface. And this is the most important one, because you can have this system as a dimer, let's imagine two monomers as dimers, but what you really want to know is the most stable structure that it's most probably to be found. So with the potential energy surface, we are making that relation between how the structure is behaving and the energy in general. So yeah, we're using potential energy surfaces.
So actually, if I may ask, actually, what is your environment? Actually, you work with Professor Attila Csásár.
Yeah.
And what about the group of Attila? I mean, does he has a big group? Can you interact with other students?
Yes and no. Because I started as, I'm the only PhD student at the moment, but we have a master's students and 2 other postdocs. So mostly what I have learned at the end of these, let's say, 2 years, is that everything has been taught from them to me, and Professor Attila, evidently, he has been guiding me, and all of the group interacts with me most of the time.
So You're working at physics department or chemistry department?
And the chemistry department. But curiously, there is two buildings, one of chemistry and one of physics. And even though I'm in part of the chemistry department, I'm in the borderline between chemistry and physics, so I'm in the physics ones.
Are you in touch with some other like experimentalists, for example, or?
Yeah, but not from my area, because I'm also part of the PhD school, HVC Georgi PhD school, which pushes to interact with other PhD students that are not studying the same field as us. So I'm interacting with experimentals, organic chemistry mostly, analyticals, and environmental.
So, but as a part of PHYMOL group, actually you traveled to other labs. So can you tell me about your visit in foreign lab?
Yeah, of course. I visited in my second month the Nijmegen, which is Radboud University. And I interacted with Nikhila Chandran. They are working in collisions and quantum scattering also, which is in general.
So those are like similar skills which you try to learn, right?
Yeah, but I think that also was very nice to go there because I was in touch with the experimentals in general, not also with the theoreticals one. But Professor Herrit was my supervisor in there directly, and he introduced me to the experimentalist in that building. And they also have a very big machinery where how can they determine the collisions in the speed, the lasers, the gases, everything.
So don't you regret that you're not experimentalist?
Oh, not at all, no. No. They spent most of it.
Why?
Because the experimentalist, when I arrived to the lab and they asked them, like, okay, I'm here because I want to know more. If I'm going to the theory, I want the theory part to be described, the whole scenario in general. So I was asking plenty of questions, and at some moment they were very surprised. The whole group that is composed like for 12, 16 people, they were very happy to show me around, and they were asking me like, why a theoretical chemist would like to know about experimentalists? This is new. Why are you here? And it was very nice that they gave me some, let's say, some details. They gave me some feedback. They gave me some approaches like, oh, don't treat this molecule in this way. Oh, we had noticed that this one is very tricky. You should be aware of this and this paper. Or I even made some connections with some of them, and they told me like they were working with the experimental part of CO dimer. So, well, that it's my general topic. So I was very excited that the community or the job that I was doing,
friendly, right?
Yeah, but it was not that small. Actually, that was bigger than I thought. So, yeah.
So during the final training schools, what did you learn particularly? What was useful to you?
With plenty of things, but mostly programming. For example, I work a lot with how to do some benchmarkings. So most of the things that I have learned from Molsci and from Konrad Patkowski had been plenty of help. I've been programming with Cypher, and those two approaches.
So like you write Python way?
Mostly Python. I prefer Python, but yeah, Fortran is not my favorite, but Python has been very helpful for me to just launch plenty of calculations using just one script, and then just have everything in Jupyter notebooks. That's very simple. That simplifies life.
So like you just press one button and you have a table with results at some point.
Yeah, and I think that's better because at the very beginning when I recently started the PhD, I spent like weeks and months just to wait for the calculations, expensive ones, to finish. And at some point you got sad that you are expecting for the results to be, let's say, in 2 weeks, and it's not. It takes more time. So if you just use this programming, it will, I mean, I program it in such a way that I just open an Excel file and then the result is going to be there. So now,
Nice.
now
So
I don't have to.
Did you have any similar experience before you started PhD?
No, not in benchmarking in this way with high calculations. I was doing completely different stuff, but now I've learned.
So you're actually approaching the absolute limits of, let's say, many electron quantum mechanics, right? Because
Yeah, we just complete basis set limit, and that also gives us an approach or an idea of how will be full CI approach in some way. But
what about Budapest? Do you like Budapest?
yeah, I was.
Because it's like was kind of new environment for you, right?
It was very, I mean, everything was new for me. And I remember that some of my friends were asking me at the beginning, aren't you scared that you don't know about the city, you don't know about the place, and you are just going there? And I wasn't really, because, I mean, at this point, I have a nationality, and yes, I was born at some place. But at the end of the day, I belong to a world. And I think that it doesn't matter where am I still will have an appreciation for the city that I'm living into. But I mean, in general, well, no, going back to the question, Budapest has received me with open arms. And Attila, who is my supervisor, he just went for me the very first day, and he just managed all of the bureaucracy for me. And then he just recommends me some places to visit, which I really appreciate. And I started to make some friends, and those friends helped me to get into swimming, my favorite sport, to take me around in the city, to even I know a little bit of Hungarian, and I can.
That's difficult.
It is, but I mean, at the end of the day, Hungarian people are nice. You just need to get to know them more. So yeah, I know like the very basics, but they actually recommend me food. When the first time that I arrived to Budapest, I remember that I asked to one person, hey, what can you give me? Or what can you suggest me? And they immediately say langos or goulash or palinkas and things like that. So yeah, it's...
Yeah, so I'm happy to hear that you're happy in Budapest. So thank you, Marlene, for the interview. And I warmly invite you to follow our channel and next interview with our students.